So my name's Jan MacArthur. I'm in the Department of Educational Research and I'll be chairing today's seminar. Just a few procedural things, if I may. So the seminar is being live streamed for people off campus. And at the end of, and you can ask questions either using the computer audio, raising your hand, or via the chat box. So please make use of the chat box as we go. The session will be recorded and the recording will be available on the department website. I ask that you all please keep your camera and off and your microphone muted during the presentation. As I said, we've got a wee technical glitch, which will mean that somebody else is controlling Mag's slides for her. So please bear with us if that causes slight delays. So it's my great pleasure to introduce Dr. Margaret Blackie to an EdRes seminar. Those of you who were with us last week will know that the UXA Geek project is rather showing off what fabulous team members we have. We had Nicole last week and we have Mags today. And for your information, Nicole, Mags, Kaylee and myself are part of what's called the society part of this broader project led by Paul Ashwin. So now those of you who know us from EdRes, you've now met the whole society group. When I was introduced to Mags about 5 years ago now, I think, going on 6, she was introduced as the chemistry person coming into the Understanding Knowledge and Student Agency project. But of course, it soon became apparent that Mags is so much more than the chemistry person, although I would say that many of us on the project, all we know about chemistry, we've learnt from Mags. But Mags is well known internationally for her chemistry work and her work on chemistry education. She's received a number of awards, both within Stellenbosch for her chemistry education and at national and international levels, such as the South African Chemical Institute. She is, for me, an incredibly valued colleague who has a strong ethical commitment that goes through everything she does as an educator and a researcher. She's passionate, curious, and really amazing to work with. So I'm delighted to have her here, and I'll just turn over to her now so you can see for herself her very, very interesting work.
Great. Thank you so much, Jan, for that incredibly generous introduction. And so this afternoon, I've decided not to talk about the UXA or Geek projects, but rather to talk about some work I've rather foolishly undertaken doing a second PhD. My first PhD was in medicinal chemistry, and the work that I'm going to talk about this afternoon is coming out of my PhD in higher education. And I've titled the talk "In Search of the Person in Chemistry Education," because this has really been my quest for the last 10 years. And Rebecca, if you can forward on to the next slide, that would be great. So my interest in, for me, my interest in education research really began from a random conversation with Jenny Case in 2008. And somehow I can't quite remember how this worked out, but I ended up coercing Jenny to take me on as a postdoc in 2009. And this paper was the product of that postdoctoral that year, which I basically spent reading a bunch of stuff and managed to get a paper out of it. So this paper, written by myself, Jenny Case, and Jeff Jarvitz, entitled "Student-Centeredness, the Link Between Transforming Students and Transforming Ourselves." And in the abstract to that paper is this sentence: "To facilitate transformative learning in higher education, an academic must know how to value the person of the student in the learning process." And for much of the last decade, the challenge has been, how do we do that in the context of science education? And that the challenge in that respect may not be obvious, But if you can just click again, Rebecca, that would be great. Looking up this notion of objectivity in science is so pervasive. And this quote, the quote in red, comes from Wikipedia. I have no shame in claiming that. This is their first sentence on the document on objectivity in science. And they write, objectivity in science is an attempt to uncover truths about the natural world by eliminating personal biases, emotions, and false beliefs. And there is the sense within science that in order to be the most objective, rational, put whatever adjective you like on that, scientist, that one must somehow transcend one's particularity. And I think that move takes us in the wrong direction. It's not a helpful way to go. And hopefully by the end of this talk, I will have convinced you of that. But it's a very strongly held belief. And the sense of objectivity in science is in one sense an ideology that is held within science. But of course, science is objective, so we don't have ideologies. So cutting through all of that is part of the challenge. Next slide, please. So against this backdrop of the desire to see this complexity of wanting to focus on the human person in chemistry education, against the backdrop of working within a field that tries to erase the particularity of the person, is a particular challenge. And for the first 5 or 6 years that I was at Stellenbosch, I really didn't know how to deal with this. I didn't know quite how to address it. And then a great opportunity came up. And if you can click again, Rebecca, that would be great. In terms of the Feast Must Fall and Rose Must Fall protests, along came the quest for decolonisation. And within the STEM environment, for the most part, in the initial phases of the call for decolonisation, most people in STEM simply ignored this, thinking, well, science is objective, so this has got nothing to do with us. And then scientists were brought into the conversation through a particular video that went viral that was known as the Science Must Fall video, which created rather a furor. And the Professor Tim Crow, who was a well-known scientist at UCT at the time, put out a opinion piece in, I forget which, it was in one of the major newspapers in the country, where the claim was simply science is objective. Therefore, this has got nothing to do with us. And alongside my colleague Hanli Ardendorf, some of you may be aware of her work, of the work that we've done together on looking at what decolonisation may look like in the STEM sphere. Our position was that we have to take this seriously, and it looks different in a STEM environment. So if you can just click again, Rebecca. The issue is that if we lose sight of the human person in science, we tend to conflate the notion that science is objective with the notion that scientists are objective. And it's this latter part that I want to seriously critique in the course of this talk. Scientific knowledge, I think objectivity is a tricky word, and I think I'll hopefully make clear in the course of this talk why that's a tricky word. But much more problematic is this notion that scientists are objective. I think some of the work that's hit the popular literature in the last few years, the work of Daniel Kahneman, Thinking Fast and Thinking Slow, the work of Mark Soames, which is much more recent, The Hidden Spring on the Development of Consciousness. All of these works are beginning to point to the fact that as scientists, well, as people, our rational explanations for how we make decisions tend to follow the decision, the whole idea of rationality and objectivity and being unemotional and all of those kinds of things, we tend to then think about the epitome of the scientist being the white cisgendered heterosexual male. And anybody who doesn't configure in that, it doesn't hold all of those particular configurations, has to somehow show that they can overcome their particular problem. In my case, is the issue of, being a girl person, that I can actually do the work of a scientist. And what I'm hoping in this work to show that is, it's just a misconception of what we are doing when we're doing science. So if you can click again, Rebecca. So just looking at the work that I began with Hanley, I'm not going to go into this in any depth at all, but Hanley and I found that LCT legitimation code theory's axis of specialization can give us a way to explain why chemistry tends to obliterate the human person. And if you can just click again, that would be great. So chemistry is the epitome of what Bernstein would call a hierarchical knowledge structure. It's really inconceivable that we would teach a chemistry course without the foundation of that course being the periodic table. Everything comes back to the periodic table in one form or another. Chemistry is substantially more hierarchical than either biology would be or physics would be, where you can teach one section or another section without having the central core. The second issue with chemistry is that there's no common sense or intuitive understanding of chemistry. So if you imagine, for example, smelling a rose, and hopefully you have that almost a visceral sense of what that experience is, and we know that actually what is happening there is that the scent molecule has a particular shape that is interacting with a receptor, a protein receptor in your nose, and that's stimulating a particular kind of experience. Whilst we can explain that on the molecular level, we don't experience the world on a molecular level. So even if you kind of look around, me sitting here looking at my desk, at the carpet, at the clothes I'm wearing, all of these things are much of our modern world, and much of the technology of our modern world is fully infused with chemistry. But the chemistry is invisible to most people who are not chemists. So we come to chemistry through a concept of chemistry rather than from an experience of chemistry. So it is a very particular kind of subject. And unsurprisingly, again, going back to the legitimation code theory specialization, the epistemic relations are very, very strong in chemistry, and the social relations are underplayed as much as they possibly can be. And of course, when you're sitting in a field that looks like this, the concept of focusing on the person, as soon as you begin to ask that question, any kind of like, how do we deal with society with respect to chemistry, all of those kind of considerations tend to get sidelined because they look like we are focusing on things that are not chemistry for the sake of chemistry, at the cost of chemistry. So if we're going to make any argument towards diversity, any argument towards focusing on the person, it has to be an argument that says this is better for the discipline itself. And so that's really where I want to go for the rest of this talk. So as I say, LCT has given me a way to explain the problem, but hasn't really given me a way out of the problem. And for that, I then turn to critical realism, which is the next slide. Thanks, Rebecca. So this is based on, much of this talk is based very much on Bhaskaar's early work, and I haven't engaged deeply in his later work, but in one sense, I wanted to do it on the work that would be problematically accepted by those who come from science. So I've limited my exploration to this so that it can talk to, his work can talk to scientists. For those of you who know critical realism, you will understand the diagram on the left. Essentially what that diagram is saying is that for Bhaskar, the real is the whole of the universe exists in that real space, and in that real domain exist mechanisms. And in terms of chemistry, how we would understand that is that the potential for a chemical reaction is always there. The reaction between two particular reagents, the potential for that is a real potential, and that exists in all times and spaces. But that chemical reaction will only actually occur at a particular point in time. And that point in time will be when those two reagents come within a particular distance from one another in a particular orientation. And if we happen to be watching that, we can then make some observations about that particular event, that particular chemical reaction. So in terms of science, we are limited to the empirical. The process of science is an attempt to explain what is going on in the real through the empirical observation of actual events. But that process will always limited by our capacity to observe. So for example, there may be many things happening in the realm of dark matter, but we have no capacity to observe those things. So there may be real mechanisms that exist in the realm of dark matter, but we have no capacity to engage with that. So science cannot interrogate those real mechanisms. So science then is the process whereby we find ways to systematically interrogate what is happening. The crucial thing here is that systematic interrogation, particularly when I think about something like chemistry, is about the intentional closure of a system. So in chemistry, in the field of chemistry that I work in, that intentional closure will be the reaction vessel. We put things in the reaction vessel and we control the temperature and we control what's in the vessel. We control the atmosphere of the vessel. We control the time for which it reacts. And all of that makes the scientist an agent in the process, not a passive observer. We are not simply watching what is happening. We are limiting, we are intentionally closing the system such that we can interrogate a particular real mechanism. The crucial thing here is the distinction between ontology and epistemology. And oftentimes that distinction is not explicitly made in our science education. We presume that what we talk about, which is our knowledge, what we talk about in terms of chemical concepts, would fall within the realm of epistemology, but we take it as an accurate representation of what is really going on, so of ontology, failing to and much of that is well established. So there's no real reason to critique the articulation, but still to recognize that there is this distinction. And we can go on to the next slide. So if we look at the development of a scientific concept, and Rebecca, I'm just going to warn you here, this is an animated slide, so I'm going to ask you to click quite often. If we think about how a scientific concept gets developed, the first part of this process is an individual scientist getting curious about a particular process and wanting to interrogate that. And so they develop an experiment or a series of experiments where they intentionally close the system in a particular way. And if you can click again, Essentially what happens at this stage is the rinse and repeat process. You do it again and again and again until it is reliably reproducible. And once it's reliably reproducible and you think you have some idea of why this is happening, you can then publish the data. And if you can just click again and maybe click twice, that would be great. So you publish the data, and that process of publication is then the first engagement with the community of chemists. Presumably the publication goes through peer review, and proper peer review, not, the predatory journal version of peer review. You publish the data, and once the data is published, then people across the world begin to experiment. And it's in one's capacity to articulate exactly what you have done clearly it's that which will determine whether that experiment is reproducible or not. So if you can just click maybe 3 times then, Rebecca. Yeah. So various people are going to attempt that experiment, and likewise will publish their results or connect with you, or however that works. And presuming that they come up with similar results, the mechanism maybe seems to hold, or maybe it will undergo some refinement in the process. So there are a couple of points to note here, and maybe you just click again 3 times. There are 3 points that need to come up here. Perfect. So the first point is that the reproducibility is a product of a real mechanism, not an inherent quality of the scientist. The crucial skill of the scientist is to be able to clearly articulate what they have done so that somebody can reproduce the work. The second crucial point is that a scientific concept requires both the reliability of the mechanism and acceptance by the community. So a concept doesn't become a chemical concept until it's accepted by the community of chemists. And the example that I usually use to illustrate this is the example of Arrhenius, who, those of you who have done any chemistry at all, certainly if you've gone through A-level or first-year chemistry, you will recognize the name Arrhenius as being one of the people associated with acids and bases. And famously, Arrhenius, who postulated this idea of the development of ions, which are charged atoms, very nearly failed his PhD, because at the time, the thought was that atoms were indivisible. And the thought of the transfer of an electron to or from an atom was conceptually impossible. As it turned out, one of his examiners did actually trust what he had done. And then his work was picked up by another famous chemist called Ostwald, who in fact really helped drive this idea into the community. But Arrhenius's idea, when he was working on his own in the lab, wasn't yet a chemical concept. It needed acceptance by the community to become a chemical concept. And the third point here is that the scientific concept will build on existing knowledge. And again, here, chemistry is so particular because we don't have any intuitive sense of chemistry. All of our understanding of chemistry is built upon our conceptual framework of chemistry. And you can click again. Thanks, Rebecca. So the implications here are that scientists are indeed exploring real intransitive mechanisms that exist in the physical world, independent of human action. Those, atoms began to exist around about 300,000 years after the Big Bang, when the universe was cool enough for atoms to coalesce, and they will exist long after humans have shuffled off this mortal coil. Science is the description of those mechanisms, which are empirically observable. And this is the bit that as scientists we forget, that description is socially constructed. And so the implication of that is that some voices may not be heard. And there's a particular example of somebody publishing a paper on greenhouse gases in the 1880s, and because she was a woman, that was, it just didn't get anywhere. And if you can click on Rebecca. So from this, where I've got to now is looking at the practice of chemistry as the confluence of these three worlds. And each of these worlds has a real mechanism in that it influences behavior, it influences how we look at things, it influences what we do. So we're looking at the physical world at the molecular level. And it's important to make that distinction because critical realism is an emergentist philosophy, which means that we need to be clear about what level we are interrogating the world. The way in which a physicist would interrogate the world is different to the way that a chemist would interrogate the world, is different to the way that a biologist would interrogate the world. And that depends on what level we are trying to interact with the physical world. So at the molecular level, and I'm not going to be too clear about the limits of that. The limits are contentious, but hopefully you will all understand what I mean by the molecular level. The conceptual world that we're talking about in the practice of chemistry is the world of chemical concepts. And the social world is the community of chemists. So again, I'm limiting that not to the whole of society, but to it is the community of chemists who most directly impact the practice of chemistry. And thus far, I think because of a misplaced understanding of objectivity, we have tried to erase the impact of the community of chemists. And if you can just click, Rebecca, that would be great. So we've tried to erase the significance of the community of chemists. And in fact, what that does is that it means that all sorts of biases and complexities and confusions end up being presumed not to exist because they shouldn't really, because we're objective scientists. But in fact, they can then happily sit in that space. And in the middle of last year, there was a huge furor at Angewandte Chemie, where an organic chemist had published an opinion piece in which he said that diversity was a threat to synthetic chemistry, and most of the board resigned. It was a massive problem. But those kinds of opinions can be held when you don't take the social world seriously. And you can click again. So within chemistry, just to sort of really dive into this, when we set up a chemical reaction, this is, obviously a random picture from the internet, but this is actually what it looks like when you set up a reaction. There's glassware involved. The magic is happening in what is in this case orange fluid. It's actually iron 3 that's in there. And when essentially what happens in terms of chemistry research, and the kind of chemistry research that I do, is making molecules. It's making new molecules, so molecules that have not been made before with a particular purpose. And my purpose is to see how they interact in the biological sphere, either killing malaria parasites or interacting with some enzyme. And what normally happens is that you read a literature procedure and it says that you get 80% for a similar kind of reaction. You get an 80% yield for a similar kind of reaction. And lo and behold, you go into the lab and you end up with like a 40% yield, which is somewhat disappointing. At that point, there are various options. You could change the solvent, you could change the base, you could change the catalyst, you could change the temperature. what one is going to change, where one starts with changing it, though, is particular. And you can click again. Thanks, Rebecca. How one approaches improving a reaction will be dependent on how you were trained and the particularities of your training. So where I might begin with changing the solvent first, the person standing in the fume hood next to me may likely change the catalyst first or change the base first. In some cases, there is an obvious thing one should do first, but in some cases, there really isn't. And this is where the particularity of the chemist then comes into view. And this isn't a problem. This is part of the joy of the complexity of this beautiful subject that we call chemistry. Sorry for those of you who love to hate chemistry at school. I quite like the subject. And you can click again. Thanks, Rebecca. So the objectivity lies in the reality and unchanging nature of the mechanism we are exploring or utilizing, not in the being of the scientist. And I'm sorry I'm saying this over and over again in different ways, but I think it has to be said because the sentiment is so pervasive. And the issue here is that we're failing to distinguish between the development of an experiment and the reproducibility of that experiment. So the development of an experiment will be particular. The person, so for example, my PhD, my medicinal chemistry PhD project was the incorporation of metals into antiplasmodial, antimalarial compounds. And that project was particular to me. I had done an honors project in an organometallic lab, and I really wanted to do a medicinal chemistry project. And the malaria thing in particular was because my grandfather had written a book on malaria in the 1940s. And so this was a project that I was super excited about doing. And there was a particularity to that project because of the sum of my life experience up until that point. And in fact, that research project, I've since moved beyond incorporating metals into molecules, but that research project is still alive and well. And one of the younger colleagues who's joined us at Stellenbosch is continuing on a version of that project. Is probably the seventh or eighth or ninth generation beyond where I began that work. So that development of that idea was particular. It was particular to me. It was particular to that time. In writing up those results, it was imperative that I wrote them up such that somebody in Cairo or somebody in Auckland or somebody in Lancaster could reproduce that experiment. The reproducibility is reliant on my capacity to explain exactly what I've done and on the real mechanism. But the particularity of the experiment that is done, that is conceived, that the initial exploration is part of the beautiful creativity that is part of science. And to erase the particularity, to attempt to erase the particularity of the person is to negate the beauty of that process. And the next slide. And you can click again, actually. So one other element I just want to point to here is the work, somebody else whose work I draw on fairly extensively is the work of Bernard Lonergan, who's a 20th century philosopher, whose one of his major projects was on figuring out what it meant to understand. And what's interesting here is that it really does, if you look at those 4 steps that he has, it really does cut through the sense of the individuality of what it is to know. So experience is everything that you bring to the table. Insight is that beautiful moment of that aha moment that all of us educators long for, that sort of shining eyes, everything, you know, the penny drops, the light bulb goes on, whatever metaphor you choose there, you can see the student beginning to understand, or in fact, in your own work, that sense of, finally, it makes sense. Judgment then is, do I actually understand in a way that is coherent with, in this case, the community of chemists? And how I work with that as a researcher, that would be through peer review. As a student, that may be going back to my textbook or asking my friend whether I am understanding correctly. And then decision making, well, what do I do with that? What's interesting here is that only insight is an individual process. Everything else is relational. Everything else is influenced by society. Insight, obviously, my conceptual understanding is framed by what's gone before, but it's hugely important here. And I think that this is one of the elements that, if decolonization is going to happen in science, I think this is one of the areas that we need to look at, is building towards a much more communal understanding of holding knowledge as the community of chemists, not as me as a chemist. And you can click again. Thanks, Rebecca. So going back to this slide here, just pointing out what is hopefully clear by now, is that the development of a scientific concept is going to be advanced substantially by having people who have overlapping but not identical knowledge bases. And there are two different ways to conceive of this. The first way, and Rebecca, you can probably click through maybe 5 or 6 times at this point. I just need the blocks to change. There we go, and stop there. If somebody is trained in chemistry and mathematics, somebody else is trained in chemistry and biochemistry, and the third person is trained in chemistry and microbiology, they're going to bring slightly different questions to bear on a similar problem. And so if they are interrogating the same mechanism, they are more likely to zero in on a more robust, more reliable, or find the limits of that articulation more quickly. But even more than that is recognizing that things like language or upbringing, in terms of, so if you imagine somebody who grew up in Nairobi, somebody who grew up in rural Saskatchewan, somebody who grew up in Mongolia, and somebody who grew up in Sydney, they will have very different environmental experiences, also potentially different language. Language is a very strong, those of you who are bilingual will know that sometimes you reach into another language to articulate something because it gives you an expression that is not available in English. And I think that we don't recognize enough how important those kinds of elements of diversity are. So we need to, recognizing that diversity of life experience will give us diversity of mental models. Even if we do have the same conceptual understanding, how we hold that conceptual understanding will be impacted by our mental models. And you can click again. So this classic Indian image, right, comes from Hinduism. Particularity of observation is not an issue if knowledge is a collective process, not an individual event. And objective knowledge arises from collective, collaborative, authentic subjectivity. And you can click again. So when we think that objectivity comes from the attempted erasure of my personal foibles, we will choose those who most closely resemble ourselves in training and in person to perpetuate the field. When we recognize that objective knowledge is situated in the joint effort of the community, it becomes immediately obvious that diversity is valuable. And you can click again. So the last thing I just want to allude to here because I think this really does have implications in terms of how we teach chemistry, because it has implications of how we think about what we're doing in terms of chemistry. And you can click again. So what this conception gives us is a distinction between chemistry as science and chemistry as technology. And the difference is what we hold as solid in some sense. So chemistry as science, what we're doing there is taking the physical world as solid and unchanging, and we are observing what's happening in the physical world. And then from there, developing concepts about what we are observing. And that's the classic way of how we think about science. We take the concept then back into the physical world, and does it hold? But I think that nowadays, most of chemistry research, and certainly most of chemistry research that's happening at university levels, is chemistry as technology, where what we're doing there is taking the conceptual world as solid and then using that conceptual world to manipulate the physical world in a particular way. So, for example, the work that I do would be very much chemistry as technology. I'm taking known chemical reactions and I'm applying them to new situations. And that's it's the use of chemistry to affect change, the use of chemical concepts to affect change, rather than changing chemical concepts by observation of the physical. And you can click again. So I think this gives us a way to think about certainly our postgraduate research, but also may give us a way to think about undergraduate teaching. I just haven't yet joined the dots on exactly the implications that this might have for undergraduate teaching. So chemistry as science can be, both of these can be put into two different levels. Level one is always essential. You can't do without level one. So level one is carefully recorded, reproducible observation. And that is what Ramhare would call descriptive discourse. Level two is the development of concepts to explain this observation. Again, what Ramhare would call the explanatory discourse. Technology likewise can be developed into, distinguished into two different levels. Level one is extending known technology to new applications. And again, for many researchers across the world, I think this is the bread and butter of the research that they're doing. And level two is developing new technologies. And if you look at the Nobel Prizes for chemistry in the last 10, 15, 20 years, almost all of them are at that level two. So things like the CRISPR-Cas9 technology is the development of a new technology which was a Nobel Prize given in chemistry. So I think this potentially gives us something to think about in terms of what we're aiming to do in undergraduate chemistry education. But as I say, I haven't joined the dots on that one yet. So you can click again, and I really am coming into land now. So the implications here is the appropriate location of reproducibility of chemistry and science in general in the realm of the real, not in the person of the scientist. It allows then creativity to come into focus. So the creative and particular flair of the individual scientist can be recognized and celebrated. It importantly, and I think this is really the heart of the contribution of this work, is that it gives us an argument for the necessity of diversity in science that is not based, that will answer the requirement of social justice, but is not an argument based in social justice. If it's an argument based in social justice, it is too easy to sweep aside because of the very strong epistemic relations and the very weak social relations. And finally, the idea that chemistry is clearly a communal activity. and the recognition thereof. And there's just one more slide because I had to put in a nice picture of Stellenbosch, which is not what I'm looking at right now, but it's the university that I work at. That's the picture of the Roy Plain and the library. So with that, I'm going to say thank you very much. And you can, great.
Thank you, Mags. That was terrific. And I think I would probably speak for a lot of non-scientists watching, where we often have been unsure when people have said, oh, that doesn't apply to science, or science is different, science is all right and wrong. And we've sort of known that these were essentialist ideas, but we didn't have a way of countering them because we're not scientists. So I think what you've done is given us a vocabulary and a path of argument to pursue. So thank you so much for that. Lovely comments in the chat, and some hand claps I hope you saw. So we've got a couple of comments you might want to respond to first in the chat, and then I will ask anyone else. Please, you can either ask your question in the chat or put your hand up, and someone will see it or shout out if I don't. So first, I don't know, Mags, do you want me to read out from the chat? Paul's made a really interesting point that it was when you made a point about something was individual. He said insight is interesting. Well, you said it is individual. I'd say it is largely collective. For example, it is not the insight that is crucial, but the articulation of the insight. This relies on a shared language, whether it is mathematical, symbolic, or word-based. Even beyond its articulation, it relies on seeing patterns, and being able to see these patterns will be largely the product of social interactions.
Yeah, spot on. So I'll have to change my argument there, Paul. Thank you. There's no moment of individual stuff that happens in chemistry, or anyway. I mean, I think though there is something about you can't. It has to happen for you. So maybe that's a point of clarity there. But I'm going to need to think about that point. It's a great point. I need to think about that a little bit more.
Thanks. Yeah, that was really useful. So, Debbie, you have a question. Do you want me to read it out, or do you want to come in yourself and ask Mags? Debbie with a Y.
Yes, sorry. I'm just trying to find my mute button. Let me see if I can get my camera as well. Hi, Mags. Yeah, so I was actually just on the heels of Paul's comment. It just made me think of a question that students very frequently have, especially in my material science. I'm an engineer, so material science class, which is about as close to chemistry that mechanical engineers will ever get. And so in their midterm test, I asked something like, what are the distinguishing features between a metallic bond, a covalent bond, and ionic bond? And I got all sorts of answers, but there was only, and I referred to how the electrons behave in that bond, that's the distinguishing feature. And the students were so frustrated because they said to me, how are we meant to know that? You know, I can tell you 100 things about what are the features of the bond. How are we meant to know what is the most important feature? And that to me is the insight part. And I think that what you were saying, I can tell them by rote, this is the answer, but for them to have the insight, for them to understand themselves why this is distinguishing, that only emerges after a conversation, after a social interaction, after bouncing ideas off each other and figuring that out. So I can think that kind of just followed on from what Paul was saying, is you can learn insight through reading the reasons, but for you to develop your own experience and insight to the insights, you need to practice. You need to practice. It's experience.
Yeah. And it's experience in conversation with the community, right?
Right.
It's never individual. Yeah. I don't know, I can.
Navel gazing.
There really is that's a hugely important part of what I think that we should be teaching them is not the fact of the difference between the bonds, but how to, it's about knowledge building, really, how that happens.
Right, how do you distinguish what are the salient features of a piece of information?
Yeah.
Or knowledge.
Yeah.
Thanks. Any other questions? And I would encourage also the non-scientists, please do feel free to ask questions too, because Mags is very good at being able to bring us in to her world. So don't be shy that you may not fully understand the world of chemistry, although I think we've all got a greater insight from this talk. I see in the chat Natasha's had to go, Mags, but she thanks you very much, and she says she's going to get in touch because she'd like to follow up on some things. So that's Natasha from our department, if you haven't met her yet.
Right.
So any other questions? So I'll here we go, Marianne. Okay, would you like to ask it yourself, Marianne, or me read it out? It's entirely up to you.
Trying to find my mute button as well. Hi, Mags.
Hey.
I had a really interesting conversation with Leslie Lagrange, who is also very interested in the idea of decoloniality within science. And one of his big issues, and I think my big issue too, is how science, or now that you've articulated it or expressed the difference or shown the difference between science and technology, I see that it's probably technology that follows the money, because it is the recognized researchers that get the money, get the funding, do the publishing, they get the students, they get the best students, they publish, they get recognized by the peer review community and by the community within their fields of specialization, and then they get more money and they get more published, and therefore the inquiry, the science, where science is going follows the money and follows the kind. And for me, this is one of the real issues that, and it's not just on a global scale with the global South battling against, Caltech and MIT and Cambridge and all of the, where the huge funding is going. But the pot that's left over is not always available to the global South. And then even within an institution like our own, we find that the money follows the recognized researchers, and it is so difficult as a newly established. And I mean, I'm old now, but I feel so, I see what's happening around me, and I see how people, especially the young researchers who are trying to get into the field, who lumped with all of the undergraduate teaching, who haven't made their mark. I don't know if that's got anything to do with anything, but I just thought that for me, it really is something that I've seen about science and technology, is that it's a problem that we have to deal with. I don't know if you have any comments on that.
Yeah, I don't really. I mean, I think that it is a big challenge. I don't have a solution, and I don't really have a. I think I'm quite pragmatic, rather than idealistic. So on issues like this, my pragmatism wins out, and I just go, okay, it's the system. I just need to work within the system.
Yeah, no, fair enough. We all do, unfortunately, but it would be lovely if those voices, the voices of the people who haven't yet been heard could be heard as well. And I just wondered if there was a link to what you're talking about.
I'm sure there is, but I think someone else will have to make it.
I think is that I see Debbie, you've come in with an answer there. Is that pretty much what you're saying too? That this is the system, we accept it.
I was teasing Marianne there.
Oh, were you? Okay, you know each other?
Because I'm in the Faculty of Engineering, but I mean it's kind of tongue in cheek, because engineering does have a really strong funding. I mean, it's one of the highest funded, probably after medicine, in terms of funded research, and the reason for that is because of the free market economy, I guess.
I wonder whether there's a connection here, and Paul may want to come in. The previous project that Paul worked on with Monica McLean and Andrea Abbas about is the issue that Marianne's raising, though, that we are even in chemistry and science and engineering, we're confusing prestige with actual achievement. So certainly looking at sociology, Paul and his partner's research found that was true, that there was the more prestigious sociology departments were not engaging in more complex knowledge. And so I wonder whether that is the way forward on that level, to challenge this idea of the dominance of the prestigious STEM centres.
I think it goes to Mags's point about the importance of diversity, because the whole point is, and it kind of relates to your earlier point and the point I made in the chat about visibility and invisibility. So what gets, all of the ways we have of seeing simplify and foreground some things and not others, and so make some things visible and some things invisible. I think what you did really nicely in your talk is saying, actually, there's good reasons why chemistry is the way it is, but in being that way, it renders the role of the community kind of largely invisible. And I think that's a lot of the strength of diversity, is that when you have more ways of seeing, then some of the things that are usually invisible become visible. And that doesn't mean it's a better way of seeing, it just means it's a different way of seeing that allows us to take account of those kind of things, and kind of just kind of draw the link that I made in the chat about this question about individual insight and how it relates to individual assessment. I'm often struck that you have students working collectively, they'll create stuff together, and some people can articulate it brilliantly and do really well. Others, people who are probably key to generating that understanding, can't, and they don't do nearly so well. And there might be good reasons for that differentiation, but again, the collective work is made invisible. So for me, it's about what you want is a range of ways of seeing, which is what diversity gives you, which kind of, in a way just reinforces the arguments you've made far more articulately during your talk.
Thanks, that's really interesting. Do you want to come back, Mags, or will we move to the next question?
No,
okay. So we've got Sally. Do you want to ask your question? Sally is a doctoral researcher in the department on our ESJ program, just so you know, Mags. Maybe Sally's gone. Are you there, Sally?
I'm here. Can you hear me?
Yes, thank you.
Yeah, it wasn't really a question. It was just, I like you, Jan, I'm not a scientist and I failed my chemistry O-level, but I was interested in the title of the talk because it was in search of the person, and I think it's very important that we recognise, as you were talking about, the particularities and subjectivities of people. And it wasn't really a question, it was just to say how much I enjoyed your talk and how important I think it is to recognise people's backgrounds, and that this concept of objectivity is a little bit of a red herring, really. And I'm really interested in the work of Sandra Harding, a feminist who you may probably do know about, the idea of strong objectivity. And I just thought your talk gave me lots of ammo because I am a teacher. I was a teacher, and I've got lots of sciencey friends who are teachers who kind of say, yes, but it's very clean, and it's you know, there's lots of, it's very attractive, it's very clean, and yours is kind of messy and poetic, and I just really enjoyed it. It wasn't a question, it was just an observation. Thank you very much. That's it.
So I'm going to add I'm going to take the liberty of adding a small anecdote there, and that is, I come from a large family, and most of my siblings are very creative. I am not. But, or at least I thought I wasn't, until I stood while I was doing my MSc in a lab in UCT and held a molecule that I'd created, and it had never existed before. And I was like, oh, this is my creativity.
Yeah, super. Thank you.
Thanks, Sally, and absolutely welcome everybody. Observations, it doesn't have to be a question. It's good to hear from you people and to hear your insights. So I think next in the chat is Louise. Oh no, she's saying thank you, but she has to rush to another meeting. I don't think there's any. I'll just check the hands up and then no, I can't see any. Okay, so I think Debbie is clearly interested in this. Do you want to come back in, Debbie?
Sure. Sorry, I'm an avid chat room typist.
Well,
but yeah, I think that I'm really interested in this aspect of insight. In fact, while you were talking, I went and put Lonergan's book on hold for myself at the library. So I'm going to read that over the December holidays. But it's something that has been frustrating for me for years, is how I can teach the same content to the same group of students, and some of them just get it and others don't. And it's not that one is working harder or whatever, and somehow figuring out how to level that playing field a bit more is something that I'd love to understand and unpack. So that was just the one comment that I thought it would be great to explore that. And then actually, Mags, you're probably the right person to ask about this because of your grafted interests in philosophy and spirituality and so on. But so I read Wahid's The African Philosophy of Education book, and the one aspect that I really like is this plurality of views, that holding different views, even conflicting views in the same space, only leads to a deeper and richer understanding of or insight into the knowledge. But I'm pretty sure that's not a novel concept. I mean, that's kind of a concept that's been around since the beginning of time. Well, not of time, but of philosophic thought. So yeah, I wonder where that kind of aligns with other philosophies and how it can help in kind of debunking this idea that there's a one truth and a only truth in science.
Yeah, I mean, I think that there's a balance to be struck there, right? Of because there's power in science of the particular articulation, and because it's such a hierarchical knowledge structure, it's built on a foundation of all sorts of different things. So having multiple views of the same thing, they do exist in science, but really only at the cutting edge. Everything that we teach at an undergraduate level is like, there's not a whole lot that's particularly contentious or particularly multifaceted in terms of viewpoints at an undergraduate level. So I think kind of engaging with, again, making how we interrogate the world and what it is that we're trying to do much more explicit, I think would really help. So it's not that multiple viewpoints don't exist, but once the science has been interrogated, we kind of settle on a particular system until it fails. And then we think again. Although, as, who is it? I think it was Heisenberg, who says that, science progresses one funeral at a time. meaning that the person who holds the field, once they sort of, shuffle off the mortal coil, then a person with a different viewpoint can actually get airtime. So I think that there are different ways to look at this, but I think the multiplicity of views is not quite as easy to hold within science.
Yeah, maybe it's more the perspectives. You can look at something from different perspectives and get different insights into it. And one perspective is not necessarily better than another. And this is the thing that builds insight, I think, is coming at a problem from different angles is the experience, is the path you need to go through in order to build insight.
Yeah.
Great, this is so interesting. Now we have a question from Kung Mei. You're on mute, Kung Mei.
Sorry, I'm trying to signpost spotlight on myself to do as well, because that's what I've been doing. Yeah. Thank you so much for an interesting conversation, Max. I was wondering to which extent that's what you're trying to conceptualize is only applicable in chemistry, because I can hear some of the very similar things. I mean, education so-called is probably, we can say, is broader field or more interdisciplinary field, but if I try to really reduce the scope of educational research, actually I can see quite a similar pattern. So it was quite interesting. So I don't know whether it's really science or social sciences, everything. I just want to hear your opinion on that. Thanks.
Yeah, I mean, there are a couple of papers that I'm dying to write out of this, and one is looking at exactly that, is how for example the concept of science and technology exists within education research, right? What does that look like? And certainly within my spirituality work, I'm dying to write a paper entitled "Religion as Technology," which will, make pretty much everyone angry, but it'll be quite fun to write. But I think that the sense of the importance of diversity and not getting hooked on the deep critique of this notion of objectivity, I think, is useful across the board.
Thank you.
Yeah, thanks. Great question, Kumi. I think that's really helpful. I think Lynn had a question. It's in the chat, but I think you also had your hand up, didn't you, Lynn?
Hi, sorry, I was just making sure the household was quiet while I was talking. Yes, thank you, Mags. Great talk. I'm just thinking and wondering how you experience it in terms of both university lecturers and teachers in chemistry, thinking that if it worked for them, then they can perpetuate that teaching style, and how that in itself minimizes our chance of getting diversity into the discipline.
Yeah, your colleague Mariki Purkita's got the perfect response to that. Just because it worked doesn't mean it was good. It doesn't mean we can't do better, right? Just because we survived the system doesn't mean we can't improve it. And there certainly is a sense of, well, it worked for me, and I'm doing all right. And so I think we just need to push back against that. And my approach on that is I'll take whoever's willing to come along with me. I'm not going to, I'm not going to try and pull people dragging, kicking and screaming, because it doesn't work. But I'm going to keep talking, and hopefully as I do, more and more people will realize the importance of this.
I think that's another good answer. Sorry, Lynn. Sorry, come back.
No, I was just saying thank you. Yeah, that is it.
I think, Mags, that actually taking us back to the question I think Marianne raised earlier, that sort of answer you've just given applies there too, because I'm a big believer that thinking differently can help move change forward, and talking differently and being, prepared to challenge ideas, to bring these uncomfortable things, to, you know, to challenge this whole objectivity narrative. I'm not saying that on its own creates change, but it does no harm. I think there's one new message, and then if there are no more questions, I'll finish up, because as some of you will no doubt have seen, various colleagues are having to multitask because the technology isn't quite as it was today. So we're not seeing anybody. But any final questions before I just give you the news about the next seminar? Or any final comments, Mags, you want to make and respond to this terrific discussion?
No, just thank you everyone for attending. It's been lovely to give it, and I've been very grateful for all of the engagement.
Great, and we'll normally save the chat, and you'll be able to see that too, to pick up ideas. But I think this is great for, as I said, just this. For me, quite groundbreaking about opening and up, giving those of us who aren't scientists a chance to educationally engage with science, and vice versa. And that sort of intellectual generosity of your work is, I think, particularly important. So I would like to give a big round of applause to Mags, everyone, please, and to thank her for coping so wonderfully with the technological hitches. Thank you to Rebecca, who had to multitask and do the slides, which she did impeccably. Thank you to Kung Mei for organising this, and then indeed multitasking in terms of the technology as we were going. And thank you to Dee Dalglish, who organises all of these. And without her, it simply wouldn't happen. So I'll just close, remind you that this will be available on our website in a few days, once we have it captioned. There is also, it's probably a good time to tell you, there's an enormous reserve of fantastic seminars on the EdRes website, going back several years and covering all sorts of topics. And I even had a PhD student of mine spent a weekend binge watching EdRes seminars instead of the Sopranos box set. So, you know, really there's a lot there. So if you can, check it out. So our next seminar will again be online in the same format on Wednesday, the 8th of December. It will be presented by Professor Heather Prince from the Institute of Science and Environment at the Centre for Learning, Education and Development at the University of Cumbria. And the title is School-Based Outdoor Learning, Lessons for Good Practice. And I hope you can all see, those of you who are perhaps new to our seminars today, that even if the title doesn't look like it's your area, these are very much seminars given to the whole EdRes community. So often you'll find something, you think, oh, that's not my area, but actually it's still well worth, if you can, stopping by and listening. So thank you again to everyone. And hopefully see you at another seminar.